Welcome back everyone. In this module, we are taking a giant leap from the comfort of our Jupyter notebooks to the exciting realm of model deployment. We will learn how to transform our well-trained machine learning model into a web API that can be accessed by anyone, anywhere. So, buckle up and let's dive in. I will provide you the GitHub URL of this repository. You just need to clone this repository using git clone command and you're good to go. Before we get started, let's make sure we have all the tools we need. First, we will set up our environment by installing the necessary Python libraries. In this project, we will be using Flask to create our web API, NumPy and Pandas for data manipulation, scikit-learn for a machine learning model, and joblib to save and load our model. You can install all these dependencies in one go by running this command pip install -r requirements.txt. Once that's done, we are ready to train our model. Next up, we are diving into model training using Ames Housing dataset. This dataset is a treasure trove for anyone looking to predict house prices using real estate data. It has features like lot area, overall quality, year built, garage area, and more, all of which are crucial in determining a house's value. In our training script model training.py, we start by loading the data using pandas. We carefully select a subset of features that are highly correlated with the target variable sales price. After pre-processing and splitting the data, we train a random forest regressor, which is great choice for handling non-linear relationships in data. It's powerful, easy to use, and often works well right out of the box. Once the model is trained, we evaluate it using the root mean squared error to understand the prediction accuracy. Then we save our trained model as housepricemodel.pkl using joblib. And just like that, we are done with training part. Now comes the exciting part, building a Flask API to serve our model. Flask is a lightweight web framework for Python that makes it easy to build web applications. Our goal here is to create an API endpoint where users can send in their data and our model will predict the house price. Let's walk through our main.py file. First, we initialize a Flask app and load our trained model. We define a route predict, which will handle post request. When request comes in, the API reads the input data, extracts the relevant features, and makes a prediction using the loaded model. The prediction is then returned in JSON format. This way users can send requests with different features and our model will respond with predicted price. Simple yet so powerful. Now let's run our Flask application. To run our Flask application, you just need to execute a simple command which will be Python and the file name, which is in our case is main.py. And within a minute our server is up. So with our API up and running, it's time to test it out. You can use curl command to send post requests to the API with different input data. Let's try out two examples. I have provided both the curls in readme.md file. You just need to copy this curl and import it in Postman. Here you can see the import panel. You just need to paste your curl here and you're good to go. For the first example, we input a larger house with higher quality features. We run the curl command and the API responds with a predicted price of around 2,83,300. Now let's try a second example with smaller house that has moderate features. This time the predicted price is around 1,19,165. Impressive, isn't it? And there you have it, a fully functional web API that can predict house prices in real time. The possibilities from here are endless. You could integrate this API into a web app, build a mobile app around it, or even scale it up using cloud services. Congratulations on completing this module. You now have the skills to deploy machine learning models as a web services, making them accessible to anyone, anywhere. Remember, deployment is where the real impact of machine learning begins. So, keep exploring, keep building, and keep innovating.